Cool. So just a little introduction. Love to present to you a little bit about what it is that I do in my work as a penetration tester and kind of explain some of the differences between the different areas of practice within what's called red teaming. So just a little bit about me. This is me at CPTC in, I think this one was in San Francisco, the collegiate penetration testing competition when I was a student at Cal Poly. Currently the principal information security consultant at Triden Group, where I primarily do vulnerability management, penetration testing, and the odd investigatory research. I got to investigate an incident of business email compromise once recently, and I was able to tie it to 22 or more other potential frauds that were occurring or planned to occur, and even track down the potential perpetrator to the residential neighborhood in Lagos that they lived in. So that was pretty interesting. Before I joined Triden Group, I was a threat researcher at the cyber range at IBM Security, where I worked with Fortune 500 companies, government agencies. Think of a three-letter agency. I've probably trained them in some of their leadership, going all the way down to even members of the IRS. As I said, member and president of Cal Poly Fast, president from 2018 to 2019. I was VP before that. I was director before that. I was in marketing before that. I was in Cal Poly Fast for pretty much all 3-4 years of my Cal Poly experience there. I did compete in the collegiate penetration testing competition. The first year I started, it was a national competition, and the second year that I competed, it actually opened up to a global audience, and we had some competitors. I think it was from Saudi Arabia or Dubai, one of the two, I can't recall. So we placed third place nationally in that first competition, and then second place regionally at another competition. I, at the same time, was a novice penetration tester, started as an intern at a company in Orange County called Tavora Business Solutions. Before that, I was a wireless network engineer for a company called Event Intelligence Group. We built long-range wireless network and surveillance systems, like security cameras kind of stuff, for big events like the Chicago Marathon, the Pasadena Rose Parade, which is partially hosted by Cal Poly, and dozens of music festivals all across the country. And before that, I was, after the 2008 financial crisis, I decided that I was tired of spending what little savings I had just to get by, and decided to go traveling. So I spent almost 2 years in Southeast Asia and Australia before I came back to finish my degree at Cal Poly. And I mentioned that not to brag, but just to give you the picture that I'm a pretty non-traditional student. I didn't go to Cal Poly right after high school. I lived a life. I intentionally chose to come back to Cal Poly. And part of the reason that I'm so passionate about returning to pay it back is that it was so beneficial for me to be part of Cal Poly Fast. So I'm so grateful that you all welcome me back, and I'm proud to continue to represent everywhere I go. All right, so I do have Gabriella's camera. Thank you, Gabriella, for setting that up there, so I can see that some of you are in the audience. I generally like to do this as interactive as I can, but since I'm remote, we're doing this through Zoom. If you have any questions, maybe you can write them down and pass them over to Jenny, or if you're on the Zoom call, you can add them in the chat here, and I will get to them as you can. So anyway, when we think of the word hacker, I'm guessing that most people probably get this kind of picture in their mind, right? I've even got my black hoodie, so I must be just like one of these guys. But in reality, a lot of hacking, cybersecurity, both offensive and defensive, kind of looks more like this. I think this is at Akamai, one of the big CDNs on the network. This is not necessarily a security operations center, but it's probably their NOC, or network operations center. But just to give you an example, that you do have one guy in a hoodie there, but you also have a guy in a dress shirt. I'd like to see some women. There might be some women that are out of frame here. But the point is that cybersecurity hacking, ethical hacking, is a profession. And it's not always clear, especially when you're trying to enter into the cybersecurity space, like what all these different pieces of it are and what they mean. So I'm going to focus just on the technical, and I'm going to focus just on red teaming. And if you're old enough to get this reference, I've got ibuprofen for you. Your back probably hurts like mine does. But yeah, basically cybersecurity in general, the practice breaks down into the red team and the blue team. That's the engineering side. That's the technical side. Obviously, you've got marketing, you've got sales, you've got human resources, you've got all the other parts of a company that would occur for a cybersecurity company or for a company that needs cybersecurity. But let's just talk about cybersecurity from this framework. The red team, also known as a tiger team, that was actually the first name that I was introduced to this concept as, was tiger team. And shout out to Greg if he listens to this. I saw your comment about how we should call red teams tiger teams. I'm fully on board with that. But a red team is basically an offensive focused part of the organization. That means that they are actually going to try to break in to the systems, to the networks, to the policies, the procedures, and exploit the company. Now, some companies have an internal red team and an internal blue team, and some companies rely on consultants, third parties, managed service providers like my employer, who are basically providing these red team or these blue team services to the company. The company is large enough, hopefully they have their own internal teams, and hopefully they're working together, the red team and the blue team, so that the offensive is testing the defensive and the defensive is learning from the offensive what needs to be done better. And we call that purple teaming when you have that kind of engagement between the two. So in general, the concept of red teaming is that offensive security testing to find vulnerabilities, and the blue team is defending, identifying potential exposures or ongoing exploitation of the network, making sure that the perimeter is secure, the interior is secure, and engineering that needs to happen for that is done. Red team also means something a little bit more specific than that, and we'll get to it in just a moment. But just one more time on screen here, offensive security, red team, emulating the criminals, finding the weak spots before they're exploited by someone with bad intentions. The blue team, defensive security professionals, implementing the security controls to keep the criminals out and responding to those incidents when they're detected. And obviously, there's many different areas of blue team careers, and just as there's a few different areas of red team careers that I am going to show you here in a moment. I'm not going to touch on these too much, but if you'd like, I can give you a larger copy of this PDF, this presentation, which goes into both the red team and the blue team and some other areas of cybersecurity that you can consider in your career. But here's an example of some of the blue team areas to compare with the red team areas. So red team in general encompasses all three of these, but each of these are distinct within red teaming. And even though that one on the far right is called red teaming, it's a little bit unclear sometimes, I recognize that. So let's start off with vulnerability analysis. This is essentially primarily automated, and it's going to be identifying, quantifying, counting, and prioritizing the number of security vulnerabilities that are detected. The next evolution or advancement from that is actually penetration testing, where using the information from a vulnerability analysis, we are going to simulate an attack on those vulnerabilities in order to validate that these vulnerabilities really do lead somewhere. There's a lot of circumstances, depending on firewalls, depending on configuration, things like that, that might prevent a detected vulnerability from actually being exploitable. There's also the fact that not every exploitable vulnerability is easy to either have the configuration or the setup or the access in order to exploit them. So penetration testing is really important because now we're not just reading off of a scan of basically automation, checking the different systems in the network or the web application in order to identify common misconfigurations, outdated systems, or known exploits that are already described in the public space. Penetration testing then takes that and actually tries to break in. And once we break in, I'll show you that there's much more that happens after that level. Now, just moving conceptually here, when we go from penetration testing to red teaming, this is the next evolution. At red teaming, whereas I like to use the description of pirates and ninjas. Pirates are loud, they're brash, they knock things over, you know that they're there. That's kind of me as a penetration tester. If you were on the blue team and you're watching the logs, you're going to see a lot of crap coming from my computer, testing all the different systems, and it's going to be very, very noisy. That's okay because the blue team has been informed of my presence and my activity on the network, and they can whitelist my activity so that they don't need to respond to it directly, and they can distinguish it from other potential issues. An advanced red team, on the other hand, is not going to let the IT team know what they're doing. Obviously, there's somebody at the company that has to give approval, legal, both as well as policy approval. And a red team engagement is going to be longer term, whereas my pen tests are probably a week, 2 weeks, 3 weeks, something like that, depending on the scope and how many services and nodes I need to interact with. But a red team is going to be much longer, potentially 6 months, year long, maybe continuous. And this is where the red teamer is actually trying to not just break in and find holes, but also trying to continue to exist within the network without being identified. And the goal eventually, every red team engagement should end with getting caught. And then from there, the unraveling of how far did they get, what was the impact, what do we need to change to prevent these kinds of issues in the future. But the blue team should be responding to it as a real event, because as far as they know, it is a real event. It's only going to be the management, perhaps even executive management, that know that this incident is simulated and not a genuine threat. So I have some more details here. I want to blow through these a little bit because I want to leave room for some demonstration at the end here. But just to give a little bit more detail about what a vulnerability assessor is doing, they're mostly contracted. There are vulnerability assessments that occur within an organization, but depending on the size of your company, it's probably not done by somebody who's dedicated as the vulnerability assessor, the vulnerability management. It's probably encompassed within other security roles. However, if you can hire a consultant, a managed service provider, they are probably going to be dedicating a person and systems in order to continuously scan your networks, maybe on a weekly basis, maybe on a monthly basis, but some recurring basis in order to identify these potential flaws, communicate them to the client, and then hopefully each month, each quarter, or however, what kind of, whatever kind of cadence for updates that they're on, they're going to be resolving some of those issues, and then a new scan would occur. So some of the important skills here is you need to be able to understand, obviously, security concepts and how different systems connect together. But one of the most important things here is being able to communicate. And that's going to be something that's going to persist throughout my presentation here, is that the ability to communicate to other people, to non-technical people, to business people, to other technical people, all throughout the workforce stack, so to speak, being able to communicate security issues and concepts and the potential risk and vulnerability as a result from these issues, that's really where the value comes in. So that might be verbal, but most likely it's probably going to be in the form of the report. And for vulnerability assessment, generally there's not a lot of elaboration that goes into the delivery of this. It's going to be more of a regular pace kind of thing, just so that they can fix the systems on an ongoing basis. And that's a little bit distinct from penetration testing. My penetration testing reports are going to be much more elaborate. I'm going to be detailing the steps that I take, how far I get in the process, what I was able to exploit, what that means for the company, and of course, how we recommend that they remediate or fix those issues. Penetration testing, also known as ethical hacking, comes down to a framework of process. It's a practice, and it has these steps that I will also detail in a future slide here, where we're going to get into the framework called the penetration testing execution standard. So day to day, yeah, we're testing vulnerabilities, not just actually identifying them, but actually exploiting them in order to validate them. And ideally, if we can chain multiple attacks together or pivot from one space to another, then we can actually move from one system to another in a way that we wouldn't have been able to get to that, from A to B, we wouldn't have been able to get directly to B. Advancing to the next level of red teaming. Again, this is that serious test of the security and the incident response. And so this is going to be sustained, highly stealthy. It's that ninja approach, remember, where you're laying low and people don't know that you're there until you've done so much that there's no way that you couldn't get caught at this point. I'm far from a red teamer at this point. I aspire to grow in my profession and my career, but this is something that's like, at this point, you're probably writing your own malware. You are, whereas as a penetration tester, I primarily rely on already existing proof of concept code. I might need to modify those or reconfigure it in order to get it to do what I need. I might write some Python scripts or Bash in order to run multiple tools from one to another, passing information between each other, but I'm not really to the point where I'm developing my own shell code or exploits or payloads or anything like that. A real red teamer probably would be doing that in order to maintain the position that they're in. Okie dokie. So overall, some of the most important skills that you can have for being anywhere within the red team is first and foremost analytical thinking, but also creative thinking. Not being such a rigid thinker where you can't think outside of the box, because you're going to be put in situations that are different pretty much from assessment to assessment. Another thing is a really high standard of ethics. I cannot emphasize this enough, how important it is that each participant on the red team has extremely high standard of ethics. It's true for blue team too, really, overall, but we're being given privileged access to systems, networks, databases, and being trusted to treat them with respect, treat them ethically and legally. And while we have permission to exploit, that doesn't mean that we have permission to damage. That doesn't mean that we have permission to steal. And that also means things like on LinkedIn, for example, if you look at my recommendations and my skills that people have endorsed me for, I only put up skills that I actually have. I only put up certifications and experiences that I actually have. But I found out recently that a lot of people on LinkedIn and other networks like that, they just buy the likes, they buy the endorsements, they buy the connections. And to me, that's very contrary to the ethics of somebody in my position. And so while somebody recently asked me to endorse them for, if I have had business experience with you, I'm absolutely happy to endorse you for what I had experienced. But if you're going to ask me to endorse you for something I haven't had experience with, that's not me. I'm not going to do that. So I hope that you have a similar perspective there. With great power comes great responsibility, right? And just because we have the capability of performing an Nmap scan, finding a vulnerability and exploiting it, doesn't mean that that's what we should be doing. If we have the capability, we need to know how to control it as well. And then getting back to, again, the communication level, being able to explain hacker methodologies, the criminal mindset, the technical paths to both the technical people, the engineers, as well as non-technical people, perhaps the users, perhaps the management, perhaps somebody who wants to buy the services that you're selling. On the technical side, the hard skills, definitely need to know both Windows and Linux. That's going to be critical for your career. Both Windows, don't just think about like Windows Home, think about Windows Professional, Windows Server, Windows Networking. So if you're not familiar with Active Directory, highly suggest that you learn how an enterprise network works. And that's not always easy. You don't necessarily have access to a lot of that until you get to school. You guys are working on an Active Directory network there. And also when you're in a workplace, then most of the computers are connected by Active Directory. But Linux, it's just another operating system. Don't be afraid of it. It does have a command line. So does Windows, so does Mac. Command line isn't anything to be afraid of. All you're doing is, instead of clicking a button, you are telling the computer exactly what to do. And since computers interpret things pretty literally, you have to understand exactly what you're telling it to do. Otherwise, you can do something, accidentally RF your instance or something like that. Programming is definitely important as a concept. I want you to understand programming. I want you to be able to read functional code, understand things like for loops and if-then statements, understand how you can, at least theoretically, pass information from one application to another. But being a software developer isn't necessarily the most important thing. If you really want to become an advanced red teamer, I highly recommend that you would learn things like machine code, essentially, assembly, or at least C and C++, something that's getting a little bit closer to the actual computer itself. If you're using any of the higher level languages, or something that's not interpreted, like a scripting language, those are things that are a little bit easier to work with, but you don't get the real technical fundamental understanding of how the system works underneath. And that's where we have to rely, we in the CIS department have to rely a lot on our computer science friends, because I don't understand how a heap stack works. I don't know how memory is addressed. Like, that's beyond my technical knowledge. And in order to advance, that's something that I'll definitely need to be learning. Another thing that's not really listed here, that wasn't such a prevalent thing when I was a kid, when I started studying, is web applications. Web applications, mobile applications, and of course, APIs, which is what tie those together, make them something that you can actually interact with the server on. So if any of those areas interest you, another area would be cloud. I highly recommend that you dig in to that environment and learn what it takes to at least operate within that environment, if not be a super user, be an administrator in that type of environment, an engineer, change things. And that's really kind of the basis of hacking, is understanding something well enough to make it do something different that maybe it wasn't actually designed or intended to do. There's a few toolkits here. I'm going to demonstrate Kali Linux and Metasploit framework. And of course, networking is absolutely important. If you don't understand what ports are, why they are relevant to the discussion, go please set up a secondary router, start learning how to configure it, connect other systems to it, do network scans, and you can start to learn the kind of things that that lead to being able to be an engineer, a penetration tester, in any of these careers. All right, so my next step here is I'm going to kind of walk you through the overall steps of performing a penetration test. Before I jump into it, is there any questions that we have so far? Pull up the chat.
Hi, yeah.
I spoke on my own mic. Hello?
Yeah, go ahead.
Okay. Yeah. Okay. I spoke on my own mic and that constant echo, so sorry about that. I was wondering if you had any suggestions for those looking to maybe practice some of these skills like NVAP scanning and Metasploit.
Definitely.
If they're on campus Wi-Fi.
Yeah, I'm going to share some resources at the end here, but the competitions, CPTC and CCDC, are absolutely awesome for getting you exposed to these areas. VulnHub is a virtual machine hosting site that provides very many Linux distributions that are intentionally configured to be vulnerable. I'm going to demonstrate one that's called Metasploitable here in a second, and I'll have a list of resources at the end. And if I think of any others, I'll add them to the chat as we get closer to the end.
Cool, thank you.
Any others? I know that I covered a lot, but is it generally pretty clear about the differences between vulnerability scanning, or vulnerability assessment, I should say, penetration testing, and red teaming?
It sounds like we don't have any questions about it. Perfect.
Cool. All right. So let's explore the penetration testing execution standard. This is a document that's online, pentest-standard.org. I highly encourage you to check it out. And it goes through the general steps that need to be taken in order to perform a penetration test. It's everything from the initial communication with the client to information gathering and threat modeling. And we're going to get into the kind of stuff that we had talked about: vulnerability analysis, exploitation, what you do after you exploit, and then, of course, the reporting. So pre-engagement is really important because this is where we find out what the rules are for the engagement. Am I performing only a particular type of test? Am I using only a particular type of method? Is it no holds barred? What is the scope? And by scope, I mean, what am I aiming at? What am I allowed to aim at? And what is out of scope? What am I not allowed to aim at? Methods could be things like binary exploitation, or it could be social engineering. And so identifying what the customer is really looking for and what type of experience or assessment that they're really looking for is the basic key points here. Also, of course, we need to figure out how and when and how much payment is going to be delivered, as well as who I'm going to communicate with during the assessment and who needs to communicate with me and how they're going to communicate with me if there's any issues that they detect where something needs to change. So in general, it's going to focus mostly around the scope, which could be IP ranges, domain addresses, API nodes, or in some cases, if we're doing mobile tests, it could be a particular app in the App Store or an APK that they provide, basically saying, here's what your targets are, and here's how you're allowed to go about it. And then everything will follow from there. And generally, the first step of actually beginning the assessment is performing some kind of intelligence gathering. It's often referred to as OSINT. It's not necessarily limited to OSINT. OSINT is the open source intelligence gathering. And that means using third-party or publicly available sources to perform reconnaissance without touching the target. Now, there's a whole bunch of websites online which already conduct network scans of different systems on the internet. And if the target that we're looking for is a www.domain.com or an IP address which is accessible over the internet, there's a good chance that one of these services has already done a little bit of investigation on that without poking them, just inquiring. And if we are on a red team engagement, we would want to rely on open source information as much as we can early in the process, because then we're not touching the targets. On a typical penetration test, this is more focused around getting context about the environment. So maybe if I am testing a particular organization and I want to find out what type of internal technologies they use, maybe one of the sources that I would use is their LinkedIn. I would go to the LinkedIn pages of the engineers that work for that company. Perhaps they're software developers, perhaps they're IT engineers, perhaps they're security professionals, and I would see what tools they're certified in and which tools they list on their resume. And that's going to give me a good indication of what kind of tools I need to bring to the table and what kind of methods I should be using as well. Other things that I might be finding are there any already disclosed pieces of information about the company, about the targets, for example? And if I'm performing an internal network pen test and I find out that there's been a previous breach at the company and I can get potentially user credentials and passwords, perhaps those are for third-party services. Even those can be useful because maybe they apply to internal. Maybe one of these employees used the same password on their golf website that got pwned in 2018 as they do for their corporate email or the domain admin. Stranger things have happened. So anyway, performing some kind of intelligence gathering to give you some context and you know where to start with and how to move forward into threat modeling. So threat modeling is going to be basically taking the idea that we have this type of organization, the field that they're in, their competitors, the nature of the work that they do, or the nature of the way that they conduct business. That's going to inform what types of criminals or what types of entities might be tried to exploit them. And now, for example, if it's a government agency and they hold government secrets, it might be more likely that they would be attempted to be exploited by a nation state adversary, right? One of our near peers. Some might be Russia, China, or North Korea, or even Iran. These are all parts of the world where the government does condone some level of exploitation of other countries' environments, sometimes for espionage, sometimes for interference. But another organization like a bank might be more likely targeted by organized crime, someone who is a part of an organization that has been performing financial crimes over the internet for many years and has a process and a practice and knows what they're doing. And any of these governmental or these other organized crime groups are generally called APTs, advanced persistent threats. Other potential attackers could be political hacktivists, people that are just looking to gain access to information or to change the information or to kind of vandalize it. You see that with DDoS attacks or defacements, where somebody puts up their message on somebody else's homepage. Perhaps, as an example, the International Monetary Fund. If a political hacktivist was motivated to, kind of shame something that they were doing, they might exploit the homepage, change the homepage to a message that's their own message. And that might be more likely than the organized crime. And then, of course, you've got other groups like skiddies. Skiddies are what we call script kiddies, or people that have figured out how to log into GitHub, but don't really know what they're doing beyond that. And it's a potential threat as well, just like anybody who loads up the low orbit ion cannon or any of these other easy to use DDoS tools. There is a threat from that, and you have to figure out what's most likely, what the impact of those types of attacks are, and if you're going to be emulating one or multiple of these, what types of methodologies would they be using? Next, we actually get into vulnerability analysis. Vulnerability analysis is typically using automated software. Here I show a picture of Nessus. I'm also going to use OpenVAS here in our demonstration later. There are many other services. Rapid7 has their own as well. But essentially, they're looking for hosts, meaning computers, servers, nodes, and the services that run on them that are potentially misconfigured in some way or are in a default state which is known to be insecure or is outdated and potentially or known to hold vulnerabilities that haven't been fixed because this system hasn't been updated yet. So we're typically going to be using a network scanner. Obviously, if we're performing a scan of a web application or a mobile application, we'll have to use different types of tool sets, but performing the same kind of ideas. What are the functions of the application? What does it connect to? How does it do it? How does it secure it? And then, of course, once we get through a vulnerability analysis, we want to get into validation.
I do have one question from somebody, though. They asked what GitHub is.
Mm-hmm.
They said that they hear the name a lot, but I think that some of us might not know what GitHub is.
Yeah, so I will explain. GitHub is what's called a repository or a host of repositories. Repositories are a place where you can put something to access later. And in this case, they are code repositories where developers will store their application code or perhaps even documentation for that application code in a place where either their team can also access it, where they can access it from another location, or the public can access it. So GitHub is basically a place that hosts application software code. In the future, for anybody who has these types of questions, like what is XYZ, always Google it. Like Google it and then find out what the basic is. And if you don't understand what that means, then go Google what that means and take multiple layers of it. That's going to be the first step in learning anything. And if you are if you're tempted to ask questions first instead of doing that first step of, well, at least I could Google it, then you run the risk of being perceived as somebody who's not willing to put in the work. So I don't want to call out anybody in particular for asking questions, but just remember that it is important to demonstrate that you have done your homework before you ask somebody to add their time and their experience to it. There's another resource hopefully I'll remember to share at the end on how to ask good questions. It's a really good page. Anyway, sorry for that sidebar rant. Moving into exploitation. All right, so we've identified some of the vulnerabilities that are in the hosts in the scope, and now we're going to actually try to get access to them. We're going to find either administration or user connection or some service or software that's provided by that node and find the vulnerability that I can then exploit in order to get in. And it could be something as simple as default password or no password. It could be something as complicated as needing to send a piece of code to a software that it then misinterprets and does something that it wasn't supposed to do. We call that a payload. And sometimes you have to be quite clever in order to deliver that payload because there might be a firewall, antivirus, or some other system in place that's going to help defend the system and make it much harder for you to actually exploit it. And then as you get up in that scale, then you're getting towards the more red teaming side of the profession. So now that we've gotten into one of these systems, what then? Are we done? No, there's post-exploitation. That means that after we've gotten into a system, we need to figure out, first of all, what is this system? What it's used for? Is there any valuable information, loot, or connections to other systems that we can then pivot from this system to another? And also establishing persistence on this system. So I've exploited it once. I don't want to have to go through the effort of exploiting it again in order to gain access again to use this system to pivot in the network. So I might set up my own account. I might enable SSH or another terminal access. I might add a scheduled task or a registry key, something that's going to tell the system, hey, if I disconnect, open this back door for me so that I can come back in without much difficulty. And all of this time, right, when I'm done my vulnerability analysis, my exploitation, post-exploitation, I'm gathering information for the report because that's really the most important part. It's not the fun part. I'm sorry, for most of us, it's not the fun part, but it is the important part. This is really what the customer is paying for. The assessment is what's required in order to deliver what they're actually paying for. They're paying for this report that contains basically, what did we find? How did we do it? What you need to do to fix it. And this is the general structure that you're going to find pretty much all pen test reports and many professional reports kind of breaking down in this structure of, you got the contact information, boilerplate legal stuff, executive summary, and then you got an explanation of how you rank these vulnerabilities. And there's different methods to do that. Most common system is called CVSS. That's the Common Vulnerability Security Scoring System. And basically on a scale of 1 to 10, how risky is having this vulnerability in the network? And that's really hard to determine because every network, and whether it's externally facing, whether it's internal only, is going to have a different type of context. And depending on what system it is and what it's holding and how critical it is to the business, then that context may impact how severe a vulnerability is. So it takes some creativity and understanding of the bigger context in order to be able to develop this, or you can just rely on one of the common standards. Really depends on how your organization delivers this type of information. After the findings, after the metric of how we describe our findings, how we measure our findings, we're going to actually rank the findings, have them all listed out along with the recommendations for how we remediate that, any additional technical information that might be beneficial to the administrators or the engineers in order to fix things, and then any kind of conclusion that may be necessary for that report. So that's basically the overall look, the top-down 10,000-foot view of how we perform a penetration test. With that, I'm going to gather my breath for just a second here, take a drink of water, and if anybody has any questions about the process or about like any distinctions that I've failed to elaborate here on, please let me know. And actually, let's see, it looks like it's 1:42, so we're getting to demo time now.
Ooh, fancy. Yeah, we have a good 8-ish minutes, I'd say. Kind of.
Oh, okay.
Yeah, because we have another class that comes in, so.
Gotcha.
I don't actually think we have anything to clean up though, but yeah, we have a couple more minutes.
Well, let me jump straight into the demo then.
Yeah.
And,
sorry about that.
No, that's okay. Before I jump into it, my contact information, you're welcome to take this down, jordan.wheeler@tridengroup.com. And I'm on LinkedIn as Jordan L. Wheeler. So I welcome you to reach out and connect. And I did mention to Jenny, if any of you are interested in offensive security careers, my team may be expanding soon. So I'd love to see your resumes.
Yeah, if anybody wants to go and send me their resume via Discord, Slack, or email, please send that to me just so I can go and give that all in like a giant stack for Jordan.
Yeah.
Please send that to me. Hopefully, let's say by tonight. I think tonight's a pretty okay deadline for those of you who are within the meeting, because y'all were the ones who did show up for this presentation.
All right. Thank you all. All right. And just a note here, I needed to remind myself to sacrifice a goat, but I don't have one with me. So please pray with me to the demo gods that this works out all right. All right. So
we have freshmen to sacrifice.
Oh, no sacrificing of the freshmen.
Oh, I don't know. Caleb looks very sacrificable.
What are the seniors?
Nah.
If you're super senior, you're at risk of being culled.
You're mean.
All right. So right now I'm showing you a virtual desktop of one of my nodes on my server here. I've got a little home server. This is Kali Linux. So it looks just like Mac or Windows pretty much. You don't have to interact with things by the text console. There's obviously a kind of a start menu kind of thing. And you've got an Explorer where you can see your file system and everything else like that. It's free, it's open source, and it has pretty much the main tools that you might be using for a penetration test. And obviously, thanks to GitHub, you can install other software just by cloning it and launching it in your own system. So one of the first tools I'm going to use is called Nmap. It's a network mapper. It's going to scan the network that I'm on. So this is 10.0.0.0/24. That means all 255 or 254 addressable network connections within that. We're going to do a scan. And from that scan, I'm going to pipe the information into awk, which is just reading that and doing something with it. So it's taking the text, and I want to focus specifically on the things that are up. I'm going to pipe that output to a file called uphosts.txt so we can read that. And with cat, I'm going to read it so that we can actually just very quickly see what's on the network and who's up. So we're going to run that. And already it's complete. It's already outputted it to the file and read that file back to us. We've got about close to 10 or so different hosts that are available on my network. This one's going to be probably the router, just by looking at the IP starting with 0.1, and then anything else in here could be pretty useful. These might be targets for me if my total scope is the whole network. So now that we have identified these potential targets, we want to find out what's actually running on them. So I'm going to run nmap again, but this time I'm going to use a different command instead of -sn, which said, don't scan the ports, just tell me if it's up or not. This time I'm going to do default scan with -O, capital O. It's going to actually tell me what operating system is running on these systems, if it can identify that based off of what response it gets. So I got to type in my password for sudo, sudo, see. And we're running nmap again. All right, so it's already completed. It's scanned every single one of those and checked the top most common ports to see what's available on them. And it's going to tell me things like, well, as far as we can tell, this one is running Google Android 5.x. As far as we can tell, this one is running Android 4.1 to 6.0. As far as we can tell, this one is running Linux 2.69 to 2.633. That's a relatively old version of Linux, I happen to know, but I could look up to find out if that's current or not. And I also see that this system has a lot of ports open and services running on those ports. And some of them are quite useful. For example, SSH, Telnet, Login, and Shell. These are all different ways of logging into this computer without actually being at the keyboard here. So these are going to be some of the areas that I want to investigate. Also FTP, how is it configured? What are the users? Can I log into it? Can I see any files without logging in? There's a whole bunch of other systems here. And as a pen tester, I'm going to investigate each one of these. And I might also use something like a vulnerability scanner like we had talked about earlier. So let's check that out. I'm going to run an open source vulnerability scanner called OpenVOS. Just start that up real quick. I probably typed that wrong. Yep. Cool, it's already running. Hopefully it should be, I'm gonna launch it in Firefox. Oh no, I had problems with this earlier. Let me very quickly. I guess I needed the goat. Service is active. There we go, cool. Okay, so this is a, oops, excuse me. This is a vulnerability scanner. I see that we're getting close here, but so I ran a scan earlier on this host. It starts with, it ends with 126. I ran a scan on here earlier, and this vulnerability scan, I'll show you what it looks like. It's actually going to give us information about all the different detected services, scans, vulnerabilities. And so we actually have 122 different vulnerabilities, and right now it's just showing the first 10, and it's ranking them as 10.0 out of 10 and 9.8. And so I probably want to look into one of these vulnerabilities in order to exploit it. And since I already looked at these earlier, we'll just jump into, for example, there's an rlogin service running on port 513 right here. And that is known to have a default configuration that is exploitable just by logging in as root without any password. So unless the administrators have set their own root password for our login, we should be able to access it directly without a password. And I know that because it's available here. I know the vulnerability, and by just asking to log in as root on this port, now we're already in. And so who am I? I'm root at Metasploitable. IP configure, we can see that I am on 10.0.0.126. And now any of these other vulnerabilities that are listed on the vulnerability scanner would be something that I'd need to investigate as a pen tester, learn how it works, and try to exploit it in the system within the scope there. I've got a few more demonstration that I wanted to do, but it looks like we're short on time. So we're just going to jump back to some of the resources. I recommend taking note of these websites here. You can Google them, so just Metasploitable. You can run that in VirtualBox. I gave you the penetration testing execution standard. Another one that you should check out is the OWASP top 10. That's the top 10 web application vulnerabilities. And some things that led to my success in pen testing would definitely be the Global Penetration Testing Competition, Lethal Security, and the Hacker Playbook by Peter Kim. I highly recommend that you buy this book, but if you don't, you can probably find it somewhere. DEF CON, get there, make a plan to, go there, and keep on doing Cal Poly fast. I love you all. Thank you so much for giving me the time to present to you, and I hope that you learned something. Please get in touch.
Thank you.
Of course, Jordan, thank you so much. Do you all have any questions before we wrap things up? Anything about possibly the resume submission I was asking for? Anything about his experiences? Anything about maybe things that Jordan did with him fast? Any cool things? Even just simple questions. Okay, so it looks like we're good.
I have one.
Well.
Oh,
Hi,
sorry.
Dan. What's up?
Hey, how's it going? What's up? Not too bad. Yeah, I do have a question. I'm currently a student in the master's program, and so I was just really curious if there was anything you wish you had done at Cal Poly while you were still here that maybe would have gotten you into a more higher position, or would have maybe shortened the time to get to where you are right now.
Take advantage of the time that you have now. If you have time, I realize master's is a little bit different because you're probably working during it, but if you can, get certified as soon as you can. CISSP, CISSP, OSCP, if you want to get into pen testing, the Offensive Security Certified Professional. If you can get that done during school, you're already a step ahead. Right now, I'm trying to get certified, but I'm also trying to work, and I'm trying to have a personal life also, and that's a tough thing to gamble, to juggle.
Yeah. Okay, awesome. Thank you.
That is a good question. Otherwise, what would be your main preferred point of contact if anybody did have questions for you? Is that Slack?
For Cal Poly, yeah, for fast Slack. Yeah. Actually, I'll share that after we stop recording.
Perfect. Okay. Thank you so much, Jordan. We really appreciate you.